To your week 14 discussion. So we're actually working with the same information, same Wikipedia page we've worked with previously that shows average height by gender in various countries and regions from around the world. And we are going to now find a confidence interval for the population average height based off of the sample data that we have. So in order to do a confidence interval, we do need both sample mean and sample standard deviation. So I've gone through the list and pulled out the ones that have the appropriate information. Your job is to run through this list and pick a particular country or region and gender from the list below. So for example, we could do, let's go with Senegal urban for our pick. So we will go ahead and take a look at Senegal urban. And then I'm specifically going to do female. So looking at Senegal, just the urban regions of Senegal, and looking at females, wanting to find our average height. We can now go on over, follow the link to the average human height by country. So going to average human height by country. Again, I chose the urban part of Senegal, looking at females. So I'm going to scroll through until I find Senegal urban. All right. So we are looking at Senegal urban, this particular row. And then I am interested in female. So the part information here that is specifically about females. The second column is our female average height, or sorry, third column, the second column with numbers. So this 166.1 centimeters is the average height for females in urban Senegal. For our sample size, look for N for sample size, and then scroll through until you see F to designate that it's looking at the female sample size. And then standard deviation, SD stands for standard deviation. And again, we're going to look for F for female standard deviation. So listing all of this information off to the side for Senegal urban, for females, we have our sample mean, our X bar is 166.1 centimeters. We have our sample size, N, is 490 females. And we have our standard deviation, sample standard deviation, which is S, is 6.88 centimeters for females. So this is all the information that you need to pull from the web page. Again, you pick your own region, pick the specific gender you want to work with from the list I gave, and then your job is to find the relevant information. If I had chosen to do males, I would have done N equals, looked for M, picked a sample size of 494. Standard deviation equals, look for M, pick a standard deviation of 8.07. So just pay attention as you're reading the chart, make sure you're getting the information for the gender that you chose. All right, so this is the information we have chosen. I'm going to go ahead and pause and switch over to where I can write on my notes. Continuing on, I've gone and transferred the information into my notes here. So again, the region or country I chose was Senegal, just the urban parts. Gender of choice was female. The sample information we found that the average height was sorry, the average height was 166.1 centimeters. That's our X bar. Sample size was 490. And standard deviation was S equals 6.88, again, centimeters. So from here, our job is to run through our 95% confidence interval. So our justification, as I mentioned in your discussion, all of these were chosen for having a good sampling technique. Anything highlighted in green on that Wikipedia page is denoted as being reasonably representative. The things not highlighted are considered to be biased samples. So we had a good sampling technique. For normality, we had our sample size was 490, which is indeed greater than or equal to 30. And so we meet our normality condition. So we can find a confidence interval because we have a large enough sample and a good sampling technique. So we can find the confidence interval. Because the normality conditions were met. And we had a good sampling technique. Next up, we're doing standard error. So since we only have sample standard deviation, so we will do S sub X bar instead of sigma sub X bar. Our S sub X bar is S divided by the square root of M. Our S was 6.88. Then we are dividing by the square root of, our N was 490. So we are looking at 6.88 divided by the square root of 490. And if we go ahead and calculate this, I end up with about 0.31. Or 0.311 if we go out 3 digits. For our T sub C, again, since we only have S sub X bar, we only have sample standard deviation, we use T. We have our degrees of freedom is 490 minus 1, our sample size minus 1, better known as 489. We have a confidence level of 0.95. We are going to go to our inverse T distribution calculator over in Canvas. We're into our inverse T distribution calculator. If it will open. It might not. Let me pull it up on my computer instead. Here we are in our inverse t distribution calculator in Canvas. Our central probability is 95% written as a decimal, so 0.95. Our degrees of freedom, we decided was 489. So we will type in 489. And we get a t-score of 1.9648. So again, our central probability is our confidence level just divided by 100%. Our degrees of freedom is that sample size minus 1. And it tells us our t-score is 1.9648. So we'll go ahead and transfer that back to our notes. And as we found, our t sub c is that 1.9648. To find our margin of error, we do margin of error is equal to t sub c times s sub x bar. Our t sub c, we're looking at 1.9648. Our s sub x bar was 0.311. So we will multiply by 0.311. I'm actually going to do the full amount without rounding. We have a slightly longer number than 0.31. It was 0.3108, 067, blah, blah, blah. So using that precise number, multiplying 1.9648, I wind up with approximately 0.61. So we have our margin of error. Finding our interval, the interval when we are working with the mean, we do our x bar, our sample statistic, plus or minus our margin of error. So our x bar, scrolling way back up, was 166.1. So we will do 166.1 plus or minus our margin of error, plus or minus 0.61. So if we do our subtraction, 166.1 minus 0.61, we are looking at 165.49. If we do 166.1 plus 0.61, we are looking at 166.71. So our interval is from 165.49 to 166.71. Our concluding sentence, we have our generic format. So I am blank % confident that blank falls between blank and blank. So I am 95% confident that we were trying to estimate the average height, so that the average height of, in this particular case, we are looking at females in urban Senegal. So that the average height of females in urban Senegal falls between 165.49 centimeters and 166.71 centimeters. So this is our confidence interval based off of our the sample that we had. So we have a fairly narrow interval. This happens as we have large sample sizes. Depending on the region and gender you pick, You may get a very narrow interval if there was a rather large sample size, or you may get a slightly wider interval if you had a smaller sample size, or smaller or larger standard deviations as well. But this is how we can go about finding a confidence interval in the context of our discussion for week 14.